Hey, let's go over the Newton's method in MATLAB for example 2. So this is just a reminder of what we did from example 2. So you can see we had this cubic equation right here. It was set equal to 0. We wanted to find the root that was in the interval from 1 to 4, and we let our initial guess equal 2. Now, let's look at what our solution was. So our solution estimate was 2.69065. All right, so we went through and we just did the calculations here. We kept updating our initial guess. You can see that changing here. It started at 2, then we got 3.25, so on and so forth. All right, so now let's do this exact same problem in MATLAB. I'll show you the code that you need to use to set it up, and we'll see if we get the same answer. All right, so here we are in MATLAB. Now the way I have my code structured is I have a script where I put my function and the derivative, and then I've got a function file that I can call whenever I need to do Newton's method. All right, so I've got two files here. So this first one we're going to look at is just the script file. So first of all, we're going to have two anonymous functions right here. So the first one is just for the cubic equation that we're trying to actually solve. So you can see that that's x cubed minus 2x squared minus 5. And then for the derivative, we just take the derivative of that function, right? So we get 3x squared minus 4x. All right, so using anonymous functions makes this really easy to set it up. Now that we've got this done, we can go and put our initial guess. I just put 2. And here is our tolerance, 10 to the negative 4. And I put 50 for my max number of iterations. If I go past 50, I've probably done something wrong. I don't want it to just keep running. Now after that, I call this function. This is Newton's, that's what I called it. And you can see we got 5 input arguments. So we're going to send down our function here. All right, so here's f. We've got the derivative of the function. We got our initial guess, tolerance, max number of iterations. So the Newton's function, once we call it, it's going to do all of the iteration, and it's going to return our approximate solution, which we're going to call x, and then we display that using this print statement right here. Now let's look at the function. So here's our function. All right. We're going to set I equal to 1. I is going to be our counter. I'm going to have a variable called error, and I'm just going to set that equal to a big number right now so we can get into the while loop. So I have a while loop structured, so it says while I is less than the max number of iterations and error is still greater than the tolerance, then we're going to use Newton's method. So here is that iterative equation right here that we've used before. All right, so x equals the initial guess minus the function with the initial guess divided by the derivative with the initial guess. So we'll do that calculation, and then we go in and calculate the error. We'll do the absolute value of x minus that initial guess. And then I'm going to use this right here. That's just to keep track of all of the calculations. So that way I can display kind of a table of the data that's generated through the method. And then finally I'm going to update I, and then update my initial guess. Okay, so now when we run it, we do run section, come over here, this is what we get. So here's our table of data right here. So you can see we have our initial guess, x naught, and if you look, this is pretty much exactly what we got on paper when we did it by hand. If you look at that second column for x naught, these values are essentially the same thing. Then you get your x values. And then this right here is the function when you plug in your new estimate x. So you can see it gets smaller and smaller until we get down here. And then that's times 10 to the negative 9. So that met our tolerance requirement. So since we met our tolerance requirement with this one, then this value right here is selected as our approximate solution, and this is the one that gets returned to the main script and gets displayed in this print statement right here. All right, so that's how you set it up. There are many different ways you can code this up. This is just one way of doing it. I like it this way because when you have it set up with anonymous functions, you can easily go in here and just change out your functions. All right, and not have to change anything else in your code. That's it for that one. So we'll leave this off here and we'll pick it up in the next video. See y'all.